the Krypton lab from OverTheWire. We're going to be doing our level 3 to 4. So well done. You've moved past the easy substitution cipher. We did the Caesar cipher in the last episode. So the main weakness of the simple substitution cipher is the repeated use of a simple key. Blah blah blah. You've intercepted a message. So on the last one, we were able to do a chosen plaintext attacks. We had the key, but we didn't know what it was. So we were able to choose plaintext, run it through the key, and be able to deduce the key based on the ciphertext that we got out from putting in chosen plaintext. This one is a little different. So we've intercepted a message or two, and the password found to the next level is in this Krypton 4 file. We've also found 3 other files that we've intercepted, which is found 1, found 2, and found 3, which are all encrypted using the same key, and the message plaintexts are in English. So that's the information that we're given. So let's go ahead and spin up our shell. And we're in our Krypton 3 box already, so let's move into our directory. So Krypton, Krypton 3, and we should see, so there's our Krypton 4. So this is the message that we're going to be needing to decode. So Krypton 4, there's our message. And then we have these 3 other files that we've managed to intercept. And if we go ahead and take a look at one of these, so let's do found 1. It's this big long string of encrypted data, broken up into little blocks of 5 here. Not every word is 5 letters, but it's just blocks of 5, so you can't tell the word lengths. It makes it a little bit more difficult. And found 2 and found 3 have the same kind of info here. So the README, let's just take a look at this just to make sure there's no additional information. No, this all looks pretty much the same. So the way that we want to be handling this is that in the English language, there's repeated use of certain letters that are just used more than others. And this is called frequency analysis. And we can take a look at this frequency analysis chart over here. And it shows that the letter E is the most common in the English language. So when you're just typing or using random sentences in the English language, E is going to be statistically the most used letter at about 12% compared to all the other letters, going all the way down to Z at just 0.07%. T, A, O, all of those follow. So if we can find the patterns in repeating letters that come up the most, we can kind of deduce what letter maps to what and be able to use these found messages to be able to deduce the key. And this is an example of a known ciphertext attack, because we've got a couple samples of ciphertext, but we don't have any plaintext mappings and we don't have any kind of encryption scheme like we had last time to be able to deduce different plaintext and ciphertext pairings. So let's go ahead and see if we can do some frequency analysis on this. So from my home directory, or from my own machine, I've come up with this script in Python called frequency analysis. And let me show you it here. So it's in Python, and it's only 46 lines, not also including the header. So what this does, and I'll break it down, is it takes 2 arguments. So we have the file name, which we specify, so we'll be using like found 1, found 2, and then the group size. Group size is how many letters that you want to be looking at a time in certain blocks. So if you set the group size to 1, for example, you'll just be looking at each individual letter. If you set the group size to 2, you'll be looking at groups of 2 and how often groups of 2 letters appear. And 3, how often groups of 3 letters or trigrams appear. So, one group of 1 would be a unigram, digram, trigram, up to a tetragram for 4. And you could specify this in the group size. So all of this stuff here, so try is just making sure that the group size is actually an integer. This is just making sure that you're given the actual arguments that you need. Down here is making sure that the file actually exists. And then once all this checking is done to make sure the arguments are good, we'll actually start going through, and this is the meat and potatoes of the script. So it's taking this line by line, and it's just cycling out all the spaces and the new line characters. So we've just got a nice sanitized string. And then what we're going to do is we're going to go through each character, and we're going to record the frequency that we see each character or grouping of characters, given the group size, into this character table, which is a dictionary, and it just has what the actual character set is and then how many times we've seen it. It's going to sort it by how many times we've seen it, so the most seen groupings are going to be shown at the top, and the least seen groupings are going to be shown at the bottom, and then it's just going to print it all out. Pretty simple here. I'll have all of these scripts that I make in these videos posted in my GroupMe, which has a link in the description of the video. And let's see it in use. So I want to get this over to the SSH machine. So I need to SCP this. So SCP is just a secure copy. So all this is going to do is it's going to take it from my native machine and put it up on the SSH machine. Before I do this, though, I want to create a temporary directory in here so we can actually put the file in there. So let's do mktemp like we did last video, tacd, which is going to give us this file here. and let's go ahead and cd into it. We can see it's empty, and we'll go over to our other script. And to specify a port in SCP, we use a capital P instead of a lowercase p that we do in SSH. So that's going to be 2231. And then we're going to specify the file that we're going to move over, which is frequencyanalysis.py, and then where we're going with it. So it's going to be Krypton 3 at krypton.labs.overthewire.org. And oops, so one thing I forgot to do is we need to specify the actual path, which is just going to be a colon, and then the actual path, which is what I copied in with the TMP. And hit enter. It's going to prompt us for the password. So this is the password that we got in the last episode. Just enter that in, and we can see it uploads. And if we go over back to our shell, we can see that it's in there. So next thing I want to do is I want to copy over that file that we want to actually decode, so that Krypton 4. So let's do cp /krypton/krypton3/krypton 4, that's the file, and we're going to copy it to this location. So let's do /, and then there it is. So Krypton 4, so let's go ahead and take a look at this. So this is what we've had before. So now what we want to do is we want to perform frequency analyses on the found files. So let's go ahead and do it on the found one. So let's do Python 3, and then we'll do our file, so that's frequencyanalysis.py, and then we'll specify the location, so Krypton 3, and found 1, and then the group size. So let's do 1, so just do character frequency analysis, and we can see it spits out the frequency of all the letters. So we see that S appears in that message 155 times, C 107, and so on. So from this frequency analysis chart, it would make sense that the S, since it's far and away the most seen letter, would correspond to E. So anytime you enter E in a plain text message, it would encrypt to the letter S. So let's check that out with found 2. You can see we get the same kind of result here. So S is seen far and away the most, and found 3 should have the same result, and it does. So the way I kind of want to record this is in TextEdit. I'm just going to open up and just kind of start our tr command, and we can use this tr command to do our decoding one by one. So we know that all S's are going to correspond over to E's. So from here, we need to kind of do some guesswork, and this is why I'm doing this is why I'm recording it like this. Because if we make a mistake or if we assume incorrectly, we can always just go back and look at the history of what we've done with changes and go from there. So this is going to be kind of some guesswork, but we can make educated guesses based on frequency analysis. So I also want to look at the trigrams. So if I go, let's do found 1, and then set the group size to 3, we're going to be looking at groups of 3 letters and see which groups of 3 letters pop up the most. So if I scroll up, there's lots of groups of 3 letters. We can see that far and away the most common 3-letter pattern is JDS, coming in at 19, which is head and shoulders above the rest. The most common trigram in the English language is the word the, THE. And this makes sense because we already think S corresponds to E, so JDS would probably be J would correspond to T, and D would correspond to H. So if I run this on found 2, we might find the same thing. And sure enough, we do. JDS is far and away the most common trigram in that message. So we can go ahead and probably safely bet that THE corresponds to JDS. So let's go back into our text edit, and we'll do JDS is going to correspond to THE. So I'm going to go ahead and copy this tr command, and we'll put that in there. Now I'm going to do cat Krypton 4, and then pipe that to our tr command. And now this is the string that it pops out. So let's go ahead and paste this into our text string here. Okay, so I've color-coded all of the characters that we have already translated. So all of the T's, H's, and E's in this message are color-coded now. So we can kind of start picking apart and making educated guesses as to what the password might be. So we see this pattern here. So we have a THE here, so maybe this is the word the. So we can kind of separate that out. It's hard to make any other kind of assumptions based off this, but we can keep going and we can keep making guesses. So let's see. So let's run our frequency analysis again for the 1 characters. So we see S is the most common, followed by Q. So if we look at our frequency analysis again, T we would suspect to be the second most, but we already know that T corresponds to J. So our next best educated guess would be that Q corresponds to A. So let's go ahead and make that guess. So we'll say Q is going to correspond to A. And then we can run this. It wouldn't really make sense to run this again because there's no Q's in here, so it wouldn't make any notable changes. So we'll keep that on the back burner. So Q would correspond to A, and then maybe we'll keep making our educated guesses about what these passwords could be. So for my first couple guesses, this is kind of what I've tried to get at here. I made a couple guesses, they turned out to be wrong, so I'm gonna try this one. This is the one of them that I kind of got a little bit of a breakthrough on. So I'd encourage you to just kind of try your own guesses, put them in. If they don't look like they work, take them back out and try other guesses based on the frequency analysis. It's kind of a guessing game. But so let's go ahead and run this tr command on our Krypton 4. So Krypton 4. This isn't something I broke in my first try. It's a lot of guesswork. So let's do cat Krypton 4 and then pipe that over to our tr command. And now we get this new string here, and this is making a little bit more sense. So let's paste this in here. Okay, so running this tr command, we come up with this string, and the blue ones are the letters that we've decoded so far, and the white ones are the ones that we've yet to decode. So we can kind of start making sense of this and make more educated guesses. So we have the first word is well. So let's see, we have our the from before, so let's separate that. We have this kind of word here, this might be level. Everything else kind of tough to make assumptions on. So let's go ahead and say that I is going to correspond to, let's copy this over to the next line. So I is going to correspond to our, so I would correspond to V, and let's see, this is probably one word here. So well done would make sense, so probably W corresponds to D, and G corresponds to N. That can make sense. So let's go ahead and run this again. So tr command, so let's do the same command from before, and run it with our new tr command, with our new guesses, and we get this one. So from this we can keep kind of guessing. So we have well done, a level, something, 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 something. I'm guessing this is password, just because we have a double letter here, which could be 2 S's, and then this would be like WRD. Oh, this is decoded already. So let's, yeah, the W's are decoded. So let's see if we can do this as password. So let's copy this over, and we'll keep going on our investigation here. So Y is going to correspond to P. Make a little bit more room here. A is going to correspond to, oh, this A is already decoded. A is going to correspond to that. U is going to correspond to S. N is going to correspond to R. And let's see where this gets us. So we'll run this tr command again. So cat Krypton 4 into our tr command, and that's going to pop out this string here. So we look like we're pretty close. So well done, the level, something password, something is this. So this is going to be our password here. So I'm guessing C is going to correspond to I, because that should be the word is. And we're going on to level 4, so I'm guessing X is going to be F. X is going to be, oops, F. And then M is going to be U. So now, let's see. So the only thing that we have left, so this is going to be 4, so M is going to be U. So the password is something RUTE, and there's only a few letters that we can guess for that. And I'm guessing it would be brute. So let's go ahead and log out and go into our Krypton 4 and try brute in all caps. And there we go. So that's the password for the next one. So this kind of just showed how frequency analysis was used along with digrams, trigrams, and unigrams to make educated guesses that could be wrong along the way, but to use the ciphertext messages that we have to be able to deduce the encryption scheme in a substitution monoalphabetic cipher. Thanks for watching.